Hey, it's on. Hi, folks. My name is James Pennick,
Good evening, everyone. My name is Mujib Wahab.
and today we're going to talk to you about Attestable service identity using something called Copper Argos. We're from Oath. It's a house of brands you're familiar with. It's up at the top of the screen in case you don't recognize the name. Okay, so to talk about instance identity or service identity, let's kind of understand what identity means. Now, the more common and understood facet of identity is user authentication, and this is something that's more or less a fairly solved problem, solved in 100 different ways. So LDAP, Active Directory, Okta as a commercial service that's out there. There's a lot of different approaches to this. Service authentication, however, inside of infrastructure is not dealt with nearly as well. So the problem with service identification or authentication is the use is services that need to be uniquely identified in some fashion, or more accurately, instances that have to have a unique identification that they can use to communicate with one another under a service. Now, a service think of a service as an application, and instances, then there are many instances that run that application. So if you have a website and you have a web front end and an application API tier, so you have a web service and you have an API service. And the instances within these need to be able to communicate to one another, and they have to be able to trust one another. Different organizations handle this in different ways. Some use just IPs and ACLs. So you set a network ACL and you say this IP address can talk to this IP address on this port. Or another way is you can configure mutual TLS manually by putting X509 certificates on each host and making them trust the other's self-signed certificate. There are a lot of problems with managing unique service identity and infrastructure. And the root of a lot of common infrastructure scale problems all stem from this common problem of being able to understand who a user is, understanding what a service is, and being able to enact policy that allows different services to communicate with one another. For example, I referenced network ACLs as a way of controlling which instances can talk to each other. Well, if you follow that pattern, what you end up with is hundreds or thousands, or in our case, millions of network ACLs. When you have enough instances, your network complexity gets huge, and it becomes very difficult to do something as simple as just add a rule to your firewall. You also find that you have all these different single sign-on systems, which are, of course, are actually different. So you have more than one single sign-on system, and then you have the problem of how do you federate them. You deal with headless automation users. So headless users are automation users, and these are when you need to have two servers communicate with one another in an automated fashion, and you have no other way of controlling the policy of how they can communicate with each other. A common design pattern is to use a headless user. So it could be Unix machines that are SSHing to one another. Maybe they have sudo access. Maybe this is you have an API, like a web service there, and you need to call that API, so you just create a new user, and then you have a system then that has some kind of shared secret that tracks. You have a shared secret that is used to then access that service, which now means, of course, you're tracking a secret, and a shared secret, by its very definition, isn't secret. If you have thousands of machines and they all have the same shared secret, and one of those machines gets owned, hacked, compromised, that shared secret is now completely compromised, and you have to change it on thousands of machines. And this really shows that in large-scale infrastructure, the smallest problems become the biggest things to solve. So what we have is a system that provides certificate-based authentication. And what this means is that every single instance in our cloud has its own identity in the form of an X509 certificate, SSL certificate for those not familiar. This means that each instance can represent itself and say, I am host foo, I am in this service. And then when these systems communicate with each other, they can do that so using something called mutual TLS. For those not familiar, that means that not only when you connect to the server are you going to validate that it has a valid SSL certificate that you trust and it can identify itself, but that server will also depend on the client having a certificate that it can then inspect and trust. These certificates are short-lived. They last about a day. And then they are frequently rotated. So even if a machine is compromised, that certificate is only valid for a day. It limits the amount of damage that can be done. I'll turn it over to Mujib.
Thank you, James. James laid out clearly what's identity, why do we need a service identity, and how the Athenz can solve. So I'm going to cover more in detail what's Athenz, how do you bootstrap an OpenStack instance with your X509 service identity, and we'll have James go through a live demo to explain a little bit more. So let me start with Athenz. So what is Athenz? Athenz is an open source system. We built it at Yahoo, now Oath. We open sourced it early last year. So Athenz provides two major features. One is the service authentication. So in that, we want to provide a secure service, secure identity in the form of X509 certificate to every single workload in your private or public cloud. What I mean, the term service here is more generic than the traditional service. A service identity can be a command, a job, a workflow, a daemon, as well as a service itself. So if you are new to the PKI, the X509 certificate basically is a digital certificate that uses a widely accepted international X509 public key infrastructure standard to verify that the public key belongs to a service identity contained within the certificate. If you think of it, it's basically a container for your public key. It basically ties your public key to the service identity represented by the certificate. So one of the security requirement we had at Oath, as James mentioned earlier, is that we wanted to make sure that every single service running within our infrastructure are communicating each other through the mutual TLS. So one way you can achieve that by going and getting an X509 certificate from public certificate authority. However, that identifies the host name, not the service. Say if you are running a service, you need to know who your tenants are, what clients are connecting to it, because you may have a specific data, you want to do some authorization on top of it to make sure the client who is trying to access is authorized to access that particular data or not. And that's what Athenz provides. So it provides service authentication. On top of it, the second feature is that it provides a fine-grained role-based access control system. So in that high level, Athenz is used to authorize access to resources. So Athenz works by defining a role that various identities or principals can assume. A role then can be referenced in a policy allowing certain action on a resource. So let me talk a bit about what is a Copper Argos thing. So we talked about service authentication, and our goal for Athenz is to provide a service identity in the form of X509 certificate to every single workload in your private or public cloud. As an organization, you may have several providers. At Oath, we use OpenStack to manage our private cloud. We use Kubernetes for container organization. We use a Screwdriver. Screwdriver, if you're not familiar, it's a CI/CD system, which again, we open source from Yahoo. And we use AWS for our public cloud need. All these providers need to have a way to give X509 certificate to all their clients. So initially, we started having all this logic in Athenz itself. Soon we realized that Athenz is an open source system. We can't keep adding different providers' logic within the Athenz. So we needed to come up with a more generalized way to authenticate the service. So we came up with a solution within Athenz called Copper Argos. So it's basically a generalized model for authorized service providers to launch other service identities in an authorized way through a callback-based verification model. So in this model, each of the provider which launches other services comes up with an endpoint which Athenz calls to validate that instance. That's exactly Copper Argos. We'll get into more detail how the whole thing works. So before we jump on to how you can bootstrap OpenStack instance with the Athenz identity, Let me quickly go over the Athenz data model. Athenz partitions the world into domain. So domain, you define your roles and policies within domain basically to provide a secure boundary. Every single domain has its own set of administrator. They manage those roles and policies. So the domain contains three major components: policies, roles, and principals. So let's start with the policies. To implement access control, we have policies in our domain that govern the use of our resources. Right? A policy is a set of an assertion. It's a set of assertions. The assertion can be, you may call it as a rules or a statement. It's all about granting or denying an action on a resource. So that's all about the policy. So let's talk about the role. So role is nothing but a group. So all the member of the group can assume that particular role. The role has like roles can have like assume all the principals are the roles. The principals can have be a real user or services. User is the one can be authenticated using whatever the identity management you use, whether it's Okta or LDAP or whatever it is. Service is another one which you as a domain administrator, you create those service in Athenz domain. And we talked about service authentications. So Athenz provides an identity for the service so that the service itself can the other service itself can identify when it's talked to other services using that X509 certificate. We will see both the identification and authorization model in the coming slides. So let me talk about how do we bootstrap Athenz identity in OpenStack. So you have authorized principal, which try to bootstrap an OpenStack instance using a Nova command. So prior to that one, the principal has to go and create the Athenz domain, define the service, and also authorize OpenStack to launch that particular service. Those are the three prerequisites. So once that's done, the principal goes and executes a Nova command, Nova boot. Apart from providing the usual Nova arguments, additional 2 arguments he provides, we usually use Nova metadata to capture those arguments. It's basically what's the domain that particular instance I'm bootstrapping with, and what service is going to run on that particular domain. So when OpenStack receives that one, we extended the OpenStack to generate an identity document. If you're familiar with AWS, it's something like an instance document, right? So OpenStack generates an identity document. It signs it with its own private key. Then it boots the instance, and it places that identity document, and it also installs one of the Athenz client called Service Identity Agent. And it invokes Service Identity Agent. The first thing Service Identity Agent does is that it creates a private key. It forms a CSR. Then it talks to Athenz to register that instance and presents that here is the identity I got from this provider OpenStack, and here is the CSR. Please sign it and give me an X509 certificate. Athenz does few checks. The first thing is number 5, which is it verifies that the service is trying to launch has been already authorized by the domain administrator, because that's a prerequisite you already authorized, so it makes sure that it's authorized. The reason we do that one is that we talked about the several providers. So we don't want that all the providers can launch any services in case a provider is compromised. So we have to make sure that you as a domain admin, you need to authorize every single service, what service the provider can launch for you. So once that number 5 gets verified, then it talks to OpenStack, said, hey, OpenStack, I got this identity document. Can you validate this for me? OpenStack is the one who signed that document, so it knows that signatures are valid. Then it also validates a few other things to make sure that instance it's indeed it's bootstrapping in near past. Then it has a few other validation. Then comes back to Athenz that okay, I own this instance, so I'm the one who's trying to bootstrap. You can go and issue a X509 certificate. Then Athenz talks to certificate signer, which is backed by the HSM, which is the hardware security model. Then whatever the CSR it got from the instance, it asks the certificate signer to sign it. It gets the X509 certificate. It goes back, the number 8, places those certificate to the instance itself. One thing you need to note here is that the private key is generated on the host. Every single instance has its own private key and X509 certificate. So there's nothing it's shared. The private key never leaves that particular instance. So that's how the whole bootstrapping works. Once the service gets an identity, X509 certificate and private key, then it can establish the mutual TLS auth to any other service it's talking to. So we got a service. I talked about the X509 certificate it gets is a short-lived X509 certificate. It's not like a typical public certificate you get, which is like a couple of years usually, right? So you got a cert, which is short-lived. How do we keep refreshing it? So let's go over how that whole process works. So start with the service identity is basically another, it's a cron. It runs very periodically. So in our oath, the X509 certificate is valid for a few days, and we rotate them every few hours. So this agent, again, talks to Athenz, and it basic number 2, it authenticates itself this time with its previous certificate. It says that, hey, here's my X509 certificate. I want to do a mutual TLS auth with you. Then it generates a new CSR and gives that CSR to Athenz. Athenz does again the same validation. Number 3, it does again to make sure that indeed that instance is still managed by the OpenStack. And the service is authorized to launch or not. Then the number 4 is it also validates to make sure that no 2 other instances trying to get the things. In case if your instance is compromised, your certificates and the private keys are stolen. If another service is trying to reference the certificate, we can catch it because the X509 certificate Athenz issued, every single certificate has its own serial number. So we know that not 2 instances can reference the same certificate. So we make sure that we verify that one at the number 4. Then again, we talk to the OpenStack to make sure that, hey, can you again validate that you still own this instance? Then once OpenStack validates that one, go back to number 6, certificate signer, sign the CSR, generate the certificate, and place it back to the instance. So that's how the whole refreshing the Athenz identity works. So we talked about service identity. Athenz also provides another feature, which is basically a bootstrapping host SSS certificate. Most of you know the tofu problem. So it's basically a trust on first use problem. So we have kind of trained our developers to blindly accept the SSS host key when logging into a new machine, or ignore MITM warning when the host key is changed, right? To solve the problem, we sign all the host key by Athenz certificate authority, and the client's configured to trust the Athenz CA mean that you can no longer need to worry when you're trying to SSH into any host. So the way it works is that same thing during the bootstrap, like it gets a service identity X509 certificate, it does 3 additional steps. So in the number 3, same service identity agent reads the SSH host key for that particular instance. It forms a CSR. Then again, when it talks to Athenz, it also presents not only the CSR generated for the service identity, but it also presents the CSR, whatever the host key it used to generate the CSR. So this time, Athenz does all the verification we talked about, then talks to certificate signer, and it generates the SSH certificate-based SSS certificate, then it places both host SSS certificate and also service identity certificate back to the instance. Then service identity agent also does the last step, which is number 9. It's update the SSH daemon configuration and restart the process, and that's how we take care of the tofu problem. We are also taking this into next level. So most of us use actual accounts in every single host, like all your engineers have access. We are moving towards making sure that no user accounts created in any other target host. We wanted to use a role-based authorization system, role-based access to the thing. So the way we are working on that one is that you build in a Bastion host, so everyone talks to the Bastion host. Bastion host talks to Athenz to see, hey, does this user have access to this particular host? If so, then it gets the next X509 SSH cert and uses that role cert to connect to the host. So that's something which we are working on. We'll update. We'll have a blog post when it's ready. So that's about, what's the next one? Okay, we talked about identity. I will quickly talk about how the authorization example also works. So Athenz also provide both centralized and a decentralized authorization system. In the centralized authorization, for example, you have a service called sports.config manager. It wants to talk to a configuration service manager service, and it wants to go and set some other settings. In this example, I'm throwing that it wants to set the max heap memory to 8 GB. So the sports.config manager got its own X49 identity. So the connection between the client sports config manager to the config manager server are mutually authenticated. Once it's authenticated, then the config manager need to see if the principal sports.config manager is authorized to set that max heap memory or not. So it talks to Athenz. So it basically extracts, once the authentication is done, it extracts the principal name, the identity name, which is the CN name within the certificate. Then it contact Athenz, does sports.config manager have access to set max heap memory setting value or not? Prior to this, the domain of administrator of the config manager already goes to Athenz. It grants permission for this particular, we talked about the role things. It goes and adds sports.config manager in respective role. So there's this particular client is already authorized. So Athenz says, oh yes, this principal is authorized to access your resource, so you can grant the setting whatever it's trying to make it. So that's how the centralized authorization model works. The decentralized authorization model, it's basically, say in the centralized authorization model, the connection between the configuration manager service to Athenz, it's again mutual TLS. So it takes like 200 milliseconds at least for any mutual TLS authentication happens. It works perfectly fine if you're trying to do a few requests per second. Say if you have a service that takes like tens and hundreds of requests per second, that really won't scale. You can't just do a mutual TLS auth to every single time to Athenz to do 200 millisecond of authorization thing. So that's how we build a decentralized authorization. The way it works is that the client, before it talks to you, it talks to Athenz. It identifies itself using its own X49 certificate. And it says that, hey, I'm trying to access this specific resource, and I want to make this specific action. Give me a role token. So Athenz checks that its policies, that, hey, yes, this principal already has access to that. So Athenz gives a role token to the user here. So number two, that principal presents that role token to the secret management system, whatever the target system, said, hey, here's my role token. I want to access your resource, and I want to perform this specific action. That system has already got all the policies from Athenz stored in local thing. So remember the domain model, we talked about domain. So all the policies within are defined within the domain. So that's a separation of policies, right? So it doesn't need to pull every single policies within Athenz. It pulls all the policies which as a domain you own it. It pulls it. Athenz provides certain libraries. So there is a policy engine runs on the box. So that secret management system here doesn't need to go to Athenz to authorize a thing. So it got the role token. It authorizes it locally using that policy engine. And it trusts that role token because it's signed by the Athenz. So all this process takes like few microseconds so that the whole system can be perform like tens and hundreds of requests per second. So that's very high level on the decentralized access control. So with that, I'll hand it back to James, who can do a demo, live demo, how all this thing works.
Great. Thanks, Mujib. Okay, so what Mujib showed, we're going to go ahead and fire off right now. So what I'm going to do is I'm going to launch an instance. Well, I'm going to log in, apparently. But then I'm going to launch an instance. Ignore that. Live demos, yes. All right, so what we're going to do is we're just going to boot an instance right now, and we're going to show what it takes to boot an instance and have it come up with its own unique identity. So create an instance called Hello OpenStack. You all know the drill. Choose my flavor. And then I'll show you, this is something we put into Horizon here. So the environment I'm poking at right now is a developer productivity environment called Open House. And what we've done as part of this is we've actually made it so that not only can you, as the operator of an application, obviously do you have a domain, and that domain contains services, roles, and other principals, but even as an individual user of this development environment, we still insist that you have your own Athenz domain. And what this means then is we're training our users to understand the value of attestable instance identity. So this means that when we build applications and we prototype things, we're doing it with every instance having its own identity and having policy that we can apply to it. So in this case, the domain is called home.penick, and the service is just named Open House, which is the name of this developer productivity environment. So it's the service name in this case is home.penick.openhouse. So I launch my instance, and that's going to take a couple of minutes, and we can go and log in and take a look at that in a minute. But to make things go a little bit quicker, I did boot this other one just a few minutes ago. So this is exactly like the other one that we're booting right now. It has its own X509 certificate. So we look and we can see it's an Athenz certificate. We can see that its common name is my Athenz service for my personal environment, so home.penick.openhouse. It's got an expiration, and it also shows any other. In this case, this is just the identity document, but it has in it also the instance UUID and the IP address. Now, that's it right there. It has its own attestable identity, boom, done. And there's simple things, to show an example of, touch to sign. All right, so I just fire up this little Golang SSL web server. And what all it does is it's very simple. It's a tiny little web server that uses the Athenz X509 certificate that is unique to the host, and it just serves a very simple web page to make a point. So this one says, hello, OpenStack. You can see now it's secure because my laptop has had a copy of the Athenz public key distributed to it. So this means now that internal applications that want to use this as their SSL certificate, done, it works. But then further than that, of course, we'll get into some of the other potential in a second. But we can see details. It's just the same certificate I just showed you. And the great thing also is, aside from the fact these instances are, these development instances, it's a VM. I can just delete it and create a new one. This is also available for bare metal. But obviously I don't care if I show everybody, I could show everyone the private key now and I wouldn't really care because this environment's disposable. But even the contents of this certificate I don't care about because there's going to be a new one by tomorrow. There could be a new one in 20 minutes if I wanted there to be. So let's also then discuss the idea of service authorization. So if we use, and Mujib has a great metaphor for this, a passport metaphor. So if your passport is your authentication, a visa in that passport is your authorization. This is Mallory, and she does have permission to enter this country. And in this case, identity is not just for a person, but it's also for a service. It's a principle, and it can be either of those things. So for the sake of this example, we have a demo set up, which if I put that middle screen, we just call this thing, and first thing we see is it didn't work, and this is not the live demo phenomenon. This demo service that's running out in the cloud, this is demanding that communication must be performed with mutual TLS, which means that not only does the web server have to prove to me it is who it says it is, But in turn, I must prove to it I am who I say I am. So what I'll do is I'm just going to go ahead and use the certificate that's on the host and connect to it. We get a different error now. We've had mutual TLS. We're able to say, hey, I am James, and it's saying I am this movie service. But you know what, James, you've not actually been granted permission to talk to me. The same thing is also that was with the, what's that? No problem. Sorry about that. This other URL is the same thing. We see that when I try and connect to this, it just says unauthorized. This first one, by the way, is just my notes. That's why you can't see it. But is this easy to see? Yeah. All right, great. Okay, so we see now that, of course, I'm obviously establishing a connection with mutual auth TLS. That's great. I'm still not allowed to talk to it. How do I fix this? Well, we can go to the Athenz web UI. Can't believe I typed my password in correctly the first time. What the heck? The web UI, of course, being that it has the keys to the kingdom, is very tightly controlled. So we have two-factor authorization. Okay. Anyway, so this is the Athenz web UI. Now we see that of the URLs I brought up a moment ago, there was one for, it's kind of hard to see now, but one for TV show and one here for movie. What we're going to do is we're going to give, let's give access to home.penic.openhouse. So we know that my instance is a member of this service. Right? It's a member of the James Penic generic development environment service. In this web UI, we've gone ahead and said, you know what, we're going to grant it access to this role, this TV show access role, and our application on the far side has been coded in such a way as to understand that only members of this role are able to have access to that. So I'm going to call TV show, and now we see I'm actually getting a result. I can make a call, I can get a thing back. I have not been granted access to movie, so as expected, we see unauthorized. If then we determine that I am no longer trustworthy of this access, it goes away. So we have instances now that all have a unique attestable identity. We can prove this instance is who it says it is. We have a signed document signed by an encryption system, a hardware security module, that says this is host foo, it has this IP address, it is a member of this service, and someone we trust to make that call declared it to be so. I am the admin of Home Penic Open House. I can make Mujib here an admin of Home Penic Open House and say he is also allowed to create instances under this service. We can prove everything as a member of this, and these are not shared secrets. There is no act of copying these secrets around and distributing and updating them. This can be part of a deeper interaction because there are still X509 certificates you'll need to pull down to the host. For example, if you're running www.bobsandwiches.com and you want to make sure you're serving over SSL, you can do that. You can make sure that you have a secure store that can only be accessed by a host authenticating itself using this, which means you don't even need to store the X509 certificate on the disk on the host in question. They can fetch it when they come online. So this has made our security posture far stronger. It has made it much easier to do business in a lot of cases because a lot of problems are solved for me. And this is only really just beginning to scratch the surface of the value that Athenz and Copper Argos have brought for us. Because this secure root of trust is the foundation upon which we can build so many other things, service discovery, which is something we'll hopefully be talking about maybe at the next summit. We're able to use Athenz integration with Keystone for user and project management, meaning we go into policy, we modify policy in Athenz, and just like that, someone can now log into OpenStack. They get their Athenz token, they take it to there's Athenz certificate, they can take it to OpenStack. OpenStack will add their project, add their user as necessary. Boom, boom, done. Something we also intend to do, and also open source, is role-based Bastion login. So if you go to SSH, like the days of me needing to have an account on a host as me need to come to an end, right? There shouldn't be user panic on a host. I'm not sure I want to say that out loud, but you can have a role user called admin and a role user called devel, right? And the act of talking to Athenz, you can say, Athenz, give me a token that will let me log into this host over SSH as this role user, and Athenz that Bastion can check policy and say, you know what, you are currently permitted to do that. And in fact, something that I want to call out in the web UI, when I go to add someone to this, you might not be able to see how this is an expiration field. I can say, you know what, I'm going to add Mujib to this. I'm going to add, not Mujib as a person, I'm going to add a Mujib service. I'm going to give sports access to this for an hour or for a day. After a day, it goes away. Automatically cleans up. Meaning then we start to take care of that dangling pointer problem where you're adding users to roles, somebody doesn't come along and clean it up. You have services that have access they shouldn't have, and then everyone's afraid to remove it because, well, when did that get added? What'll break if we take it away? Now you can make this part of how you do business to say, you know what, only add things temporarily. So we don't have that fear of change. So we talk about, okay, we can trust things are a lot more secure. We understand that we can use this to manage login for Keystone for user and project management. And there's another thing that we kind of demoed without actually demoing, but when I logged in that server, I never passed user data when I booted this instance. We have a system called Calypso, which uses Athenz policy to add users to hosts. And this is that kind of interim step before we go to role-based login with Bastion hosts. We have hundreds of thousands of servers. We have many, many, many software engineers. It's going to take a little bit of time to move the whole company over, but in the interim, we have a way now to manage users and take care of that part of configuration management on demand. So, some other resources if you're interested in Athenz. All of Athenz and Copper Argos is open sourced. The pieces that we have added to Nova are not yet all open sourced. However, we intend to do that, and we also would like to share all the open source code we write with regards to our future Keystone work. Pardon me. So our website and GitHub are up here. Lots of docs. Actually, I didn't do any of the docs, so I can say honestly, I'm impressed with them. There's a lot of means of staying in contact with the team. Obviously, at the end, there's also, if you need to, go ahead and get a hold of myself or Mujib. And please, join us. If you want to work, are interested in working on Athenz, please. All right, is there any questions? Yes, sir. If you want to use the microphone.
I have so many questions. Let me be limited to just 3. So do network ACLs go away?
Oh, I wish. So no, network ACLs don't necessarily entirely go away. However, it's a good question. Because as part of this improved posture, we can say, you know, especially as part of an organization embracing the concept of zero trust networking, we can start to say, instead of like, we're going to close this subnet off to the world, and we're going to open up pieces here and here and here and here, we can actually say, you know what, we're going to leave this a little more open and say that we don't need to worry about allowing host A access to host B in certain prescribed circumstances. We can actually leave that open and know that this is an Athenz-controlled application, and if it needs to have access at this point in time, it can.
So,
the long-term plan, though, is we can free up quite a lot of our ACLs.
are you asking mainly because what do I need to have mutual TLS auth because it's my own private VLAN? Is that why you're asking?
Well, I'm a networking guy, so I'm always
Okay.
interested in that. But there's lots of efforts to solve the explosion of network ACLs using completely different techniques.
Solving the wrong problem with the wrong tool.
It could be. It could be. I'm not going to take any position on that. But anyway, you answered my question. I have another question. Can I go move to the next one?
Sure.
So can you compare this at a conceptual level or a functional level to the SPIFFE effort and also the mutual TLS approach that is emerging within Istio?
Yeah, I know this question is going to come. So we just started working with SPIFFE to see how we can integrate Athenz with that one. So we haven't done all the work yet, but that's going to come.
But in terms of functional similarities, are they aligned? Are they replacement? They substitutes?
It is aligned. It is aligned. So we Athenz can provide a great value within the SPIFFE framework as well. So we just started looking into how we can integrate it with it.
Great.
Hi there, good talk. I'm a security architect, and I'm starting to review designs for JSON web tokens, and so, JWS, the signed tokens, and I was wondering if this solution would also manage those, even though they have a shorter time to live. Sometimes they want to increase the TTL requirements, but regardless, it's nice to have one place for provisioning an authorization access token, and also, can you talk to the audit features or reporting features of when access was provisioned? Because I'm a security person, so we ask about, audit reports and stuff. Thank you.
Yeah, absolutely. Do you want to handle the JSON bit first, and then I'll talk about the audit?
Yeah, so you can.
There.
So we were using in the past some JSON-based a short-lived token as well. But as we talked about earlier, is that we want to combine both authentication. We want to do a mutual TLS authentication. So we thought that X49 certificate-based authentication is much more secure than the JWS web token thing.
I don't disagree. I was just wondering if this platform would support both in a mixed environment where I actually do have both requirements.
I guess you could make it do that, right?
You can make it.
This token signed, so
Yeah.
it's operating as if it was, a authenticated token. I mean, it is a bearer token.
Yeah, in fact, you could make it, and like you said, that was actually exactly what this used to be. And so sometimes I still spill some old terminology where I'll say something like N token or Z token. It's pretty much exactly what it was. It's like a JSON serialized token with everything in there. We moved to certificates because for us it was better. But
Do you have a report of what was assigned at a given time frame to a user? I'm sorry if I missed it earlier.
no, and so the question is, it's her prior question, which is there a way of looking at a report of what was assigned to a user at a given period in time? And so right here, actually, just on this page, this is some of what you can see, which, how about I make it?
So the two kind of auditing things. One is like when you authorize somebody, so basically adding in a principal into a role, that role is referenced to some policy to have that role can perform certain action on the resource, right? So the key thing is that you define a policy. The whole point of the role-based access control thing is that you don't change the policy. You use a role-based thing to manage your principals within the role, right? So all the role addition modifications, it's been tracked. So there's an history so you can audit that who was added when and what time frame, right? That's the one auditing thing. Another thing you were talking about is that the certificate, when was the certificate was issued? Yes. If you remember, I talked about that if two instances try to reference the certificate, we revoke that both instance things. So we do need to have all those things stored, that every certificate, what is the serial number of that one, when was it issued? So that's pieces of information is also there for auditing purpose.
Okay, thank you. Very, very good talk.
Cool. Thank you very much.
I realize I'm making you run over, but this is fun stuff. Nice work, guys and gals, I imagine. So when you speak of services, does this also, are you able to have more than one service besides the VM itself? Meaning if I have...
Can an instance have more than one service identity? I want to say no, but the
Okay.
answer is not no.
But in the real world, yes, in the container world, we want to run
Yeah.
like one service, right? But
Right.
obviously, there is a need multiple service. Once you get the service identity, then you can use that to go and get another service identity. So there is a way to do that with the Athenz.
Yeah, and also with for containers, it is also reasonable that there's sort of a chain here where sort of I, as say a Kubernetes cluster admin, might provision a node to host containers, and then Kubernetes itself is considered a provider. So when it creates containers on that node, then they could each have their own certificate inside of them. And then on top of that, like he said, you have your root, your raw identity, like this is my raw service identity, but if that service has been added, because remember a service is a principal in the same way that a human is a principal. So that service can be added as a member of other services, which means it is now permitted to go forth and fetch those other service tokens.
And then just from, if I have a good tool, I like to use it in lots of places, hopefully only in the way designed though. So what sort of HSMs can you hook this into, and is OpenStack the only scope of the tool that you're creating right now? I hear you talking about Kube, but.
So this tool actually is currently in use, not just on OpenStack, but also in our public cloud on AWS. And you had another question. Is it in use on there? And then.
What sort of HSMs or identity stores?
Right. So for all I know, our security people might hit me if I say the name for whatever reason, HSM.
I don't need
But
to. I don't.
So I can tell you, so what we have here is a certificate signer called, cleverly named CertSignD. But what this is a fairly simple API we wrote in Go, and it speaks PKCS 11. So you can put it in front of whatever HSM you want, as long as it speaks PKCS 11, with the caveat that every HSM manufacturer seems to be implementing PKCS 11 slightly more wronger than the others. But in this CertSignD, because we run this on-prem, and do we also use this with Cloud HSM?
Yeah.
Yeah, and so we use it with Cloud HSM, so we can drop it in both places. And its API is very simple, but in fact, we kind of call out a lot of things it can do here, which is it can sign X509 certificates, it signs SSH-CA user certificates, so if you saw me using the UB key earlier, and it signs SSH-CA host certificates. But we will be open sourcing that, and it could be dropped, in theory, in front of anything speaking PKCS 11. All right, thank you very much, everybody. Sorry for running over time.
Guys.